discuss how reduced visibility affects search operations, precautions for flight during reduced visibility conditions, describe how turbulence can affect search operations. So the first is discussing how reduced visibility and turbulence affect search operations. And I'm sorry, affect is spelled improperly, but that's okay. So a high percentage of general aviation accidents have weather as a primary or contributing factor. When a small aircraft is down, Capt may be called on to search in less than ideal weather conditions. Safety is paramount. Weather will determine whether it's safe to fly search missions or not. We need to define things like navigation. Weather will have an impact on the ability to reach the search area, and the ability to perform an effective search and return to base. The effect on search, weather will help determine the starting point for a search, areas of thunderstorms, frontal activity, icing, etc. Visibility has a direct bearing on ability to successfully fly a mission because poor visibility will impede aircrew ability to locate a target. Patterns, weather has an impact on the type of search pattern flown. If low clouds exist in a search area, electronic searches may not be very effective. Keep in mind the weather in the search area as well as at the recovery base. Don't allow yourself to become trapped by the weather. Search visibility may be much worse than overall prevailing visibility reported by weather stations. So we have a lot of different types of weather patterns that can produce reduced visibility. Fog is comprised of water droplets suspended in the air, and you can expect fog anytime the temperature and dew point are within 2 degrees Fahrenheit of each other in weather observations. Fog can severely reduce visibility and therefore constitute a serious hazard to aircraft.
Can I hold just a second? Some people may not know what a dew point spread is.
Oh, okay. So the dew point spread is the difference between the temperature outside and the temperature where the air would be 100% saturated with water. And so when we have a spread that's very, very low, it means that the air is almost completely saturated with water. Once we get to complete saturation, we're looking at rain. And when it gets very close to that saturation level, we're looking at fog. It's just because there's so much water in the air, it will create fog. So let's look at rain. Rain will greatly reduce visibility and could have increases in turbulence due to convective forces, especially in cumulus type clouds. So the cumulus clouds are the ones where you typically find thunderstorms, and they have a lot of vertical buildup in them. Yeah. So when you see a cloud that varies in altitude greatly, that's typically a cumulus cloud, and it's showing lifting forces inside the cloud. Haze will cause fatigue trying to look through, just like fog. Snow is another form of precipitation that presents unique problems. We saw that it's very difficult for us to see a plane in snow that has crashed. Whiteout is an optical phenomena that can occur when, with snow-covered ground, and low cloud level decks in certain low lighting conditions can also make it difficult to see things. As sunlight is diffused through the clouds, it reflects off the snow in various directions, and the net result is a loss of any reference to horizon and lack of depth perception. We've got sun location and angles, which can obscure your visibility. And as Lieutenant Colonel Denisick said earlier, it's good to set up a scan flying into or away from the sun as opposed to the sun right in the scanner's eyes. That will make it very difficult, of course, for you to see anything. Let's talk about turbulence. So turbulence reduces scanning effectiveness because it interrupts your scan and tires you out. Be prepared for upwind or downwind turbulence when approaching mountains and peaks. So if you look at this diagram here, with the wind blowing against the peak, you're going to have the upwind on the front surface of the mountain, which is going to cause a lifting force. And then as you get on the other side of the mountain here, you'll have the downwind side of the mountain, and it'll create a force to push the airplane down and create turbulence. There are quite a few myths about turbulence, and the 5 big ones are that number 1, pilots always get a lot of warning about air turbulence. There can be clear air turbulence, so it's not always the pilot will have a lot of warning about it. Severe turbulence, another myth is that severe turbulence can break up an airplane. And actually, the last airplane to break up due to turbulence was in 1966. So it's very rare, especially with today's safer, stronger airframes. Another myth about turbulence is that when you're up at cruise altitude, it's okay to unfasten your seatbelt. Turbulence can arrive without warning, so we have to make sure our seatbelts are fastened at all times when in the airplane. Another myth is that there's nothing you can do about turbulence, which is not true. The pilots can actually choose to fly at different times when convection forces are not so strong. And then the fifth myth is that people get injured by turbulence all the time. And in actuality, less than 35 people a year are injured by turbulence, most likely to those with unfastened seatbelts. So again, make sure your seatbelt is fastened. So flight precautions. Each member of the aircrew must be vigilant during all phases of flight. So everyone in the plane has a duty to check for obstacles in other aircraft. Take into account what type of visibility you have to establish a proper scanning range. You will definitely not be the 3 to 4 nautical miles maximum search visibility of a car in the desert, as mentioned earlier. If there's fog, haze, rain, or other type of weather affecting your visibility, it will greatly lower your scanning range as your search visibility will be shortened. Be aware that turbulence and poor visibility increases fatigue. If you feel fatigue or motion sickness, be sure to let your aircrew know immediately. Someone else in your crew can relieve you for a short time. You can switch seats, as we mentioned before, or stretch. Have the mission pilot come back to the area at a later time. If you're not feeling well, it's definitely important to speak up. So obstacles and other dangers, we really have to look for tall towers, and the reason being is that tall towers always have guy wires, and guy wires may extend outward over 1,000 feet. So you can see from this picture, you can see the tower, but you can't see the wires. So how many guide wires can you point in this picture? Can anyone see any guide wires? And those are where all the guy wires are actually. They're all around the towers. And there's a little close-up picture to show you how far out those wires can go. Power lines can be difficult and even impossible to see. It's always a good idea to look out and stay clear of any type of tower nearby that could even have the remote possibility of having wires. So these guys are not having a very good day. And finally, we've got obstacles and other dangers. So we've got low-flying or heavy aircraft. It's always a good idea to keep looking out the window for any visible traffic, but low-flying aircraft can be difficult to spot because of ground cover and sometimes placement of the wing. It's always a good idea to keep vigilant and scanning for other aircraft, especially in the landing pattern. Heavy aircraft, as we mentioned before, create what we call wake turbulence, and every aircraft in flight generates wake vortices, which are caused by counter-rotating vortices trailing from the wingtips in cruise and from the outboard edge of the outboard flap on approach and landing. What it basically means is that large airplanes will create these wake vortices that go out from the wingtips and they travel down. They can cause rolling moments that exceed the roll control authority of smaller aircraft. The most dangerous time for these types of vortices is when we have a light crosswind, which can actually blow the vortices right into the path of your plane. Be especially wary of these 3 characteristics of an airplane in front of you: slow, heavy, and clean. So if the plane is large and heavy, slow, and they're in a clean position, which means that they're not using their flaps or they're using minimal flaps, there's more chance that they'll create stronger vortices, which we have to kind of look out for.